What if Mars wasn't just a destination, but a witness? What if, for one silent minute, the red planet saw something born beneath a different sun? And what if that glimpse, and barely a heartbeat in cosmic time, was enough to rewrite everything we know about the universe? Mars turns beneath a crimson dawn. Thin air trembles over its endless dunes. Above, the ExoMars trace gas orbiter drifts in patient silence, its sensors tuned not to the stars but to the gases breathing off a lonely world. Yet tonight something unexpected moves through its field of vision, something that does not belong here. On July 1, 2025, the Atlas Telescope network in Chile detected a light so faint and fast it seemed to slip through the solar system itself. Its trajectory was hyperbolic, not bound by our sun. The mathematics were clear. It was a visitor from another star. NASA would name it 3I Atlas, the third confirmed interstellar object ever observed. As this cosmic traveler cut across the inner solar system, Mars stood in its path like a silent sentinel. The planet that once dreamed of life suddenly became the observer of life's possibility from beyond. ExoMars, never meant to see beyond its host planet, captured faint reflections, spectral whispers of metallic light where none should exist. In that fleeting moment, a machine built to study atmosphere recorded a mystery older than the sun itself. Imagine it, a fragment of a forgotten system, born in a distant supernova, drifting for millennia through cold and dark before meeting our tiny Martian witness. No signal, no message, just a trace, a metallic signature gliding past the red world like a whisper in the wind. The narrator reflects. For centuries, Mars was the destination, but one night it became the observer. That night, the boundary between the known and the unimaginable blurred. The solar system was no longer a sealed realm of familiar orbits. It was a crossroads, a place where messengers from other suns could pass through uninvited, unexplained, unchained. And so, the camera lingers on the red planet as it watches the traveler fade into the black. No trail, no return, and only data, barely a minute long, beamed home across the void. Yet within that minute may lie the first proof that our universe is far more crowded than we ever imagined. Because somewhere beyond those rusted plains and solar winds, something was moving, watching back, perhaps thinking nothing of us at all. If this story of cosmic wonder stirs your curiosity, consider subscribing. It truly motivates me to create new journeys for you. Daily stories of mystery, science, and the silent beauty of space. In the quiet vault of the heavens, a whisper arrived. On July 1, 2025, a faint point of light streaked across the night sky, detected by the Asteroid Terrestrial Impact Last Alert System, ATLAS, survey in Chile. It was moving too swiftly on a path too steep to belong to the familiar circle of solar system wanderers. Within hours, astronomers confirmed it to be an interstellar visitor, designated 3I Atlas, the third confirmed object ever seen, entering from beyond the sun's domain. What followed was not a dramatic explosion of discovery, but a gradual unfolding, data trickling in, instruments pivoting, a planet quietly becoming eyewitness. The mission, known as the Trace Gas Orbiter, circling Mars, was built for the mundane tasks of atmospheric measurement, detecting methane plumes, mapping water ice shadows. But it now found itself pointed toward a ghost from another world. At the moment of detection, archival photometry from Earth-orbiting telescopes revealed that 3I Atlas may have been active far sooner than its arrival at inner solar system heights. When still beyond the orbit of Jupiter, its brightness indicated a coma beginning to form. an unexpected stir of dust and ice that challenged standard cometary models. The object's hyperbolic velocity, some 60 km relative to the Sun, announced its extraterrestrial origin, yet its behavior whispered a deeper puzzle. As weeks passed, imaging systems locked on. The Hubble Space Telescope captured the object on July 21, 2025, revealing a teardrop-shaped cocoon of material surrounding a solid nucleus. Ground-based telescopes noted a faint tail, diffuse and fleeting. Spectrographs offered hints of unusual reflectance. The surface seemed red-toned in visible light, but held a glimmer of neutrality or blue shift in the infrared bands. Then came the turn to Mars. Whereas Earth-bound telescopes surveyed from afar, the orbiting spacecraft around Mars, ExoMars Trace Gas Orbiter and its partner Mars Express, prepared for a rare observation window. On October 3, 2025, calculations indicated that 3I Atlas would pass within approximately 30 million kilometers of Mars, a cosmic near-brush, screened by nothing but the planet's quiet orbit. Instruments tuned for Martian methane now trained their gaze beyond, toward the unexpected guest. Within the orbiter's data began to emerge the first anomalies. Ultraviolet detections of OH emission at a heliocentric distance of 3.5 AU, signifying water production at a realm where water ice typically lies dormant. The derived production rate, on the order of 1.35 x 27 molecules per second, roughly 40 kilodalars per second, suggested an active area covering at least 19 square kilometers of surface. Meanwhile, infrared analysis revealed large icy grains entrained in the coma, behavior more commonly associated with solar system comets, yet occurring farther out than expected. Each dataset added a layer of mystery. What could cause such distant activity? Why did the object's surface reflect light in unexpected ways? How had this interstellar visitor arrived within Mars's neighborhood, and what did it carry with it? In control rooms across Earth and Europe, mission scientists gathered. Engineers calibrated spectrometers, cleaned imagery, stacked frames. Around them, the instrument readings flickered. Counts of photons, angles of tail departure, light curves plotted against time. The assembled charts looked routine. Nothing screamed breakthrough, yet everything pointed to the unexpected. And so the awakening of the data was not a sudden burst, but a slow, deliberate realignment of expectation. A probe built for Mars, repurposed for a cosmic stranger. An object from beyond behaving in defiance of norms. As the weeks passed, the ledger of questions grew longer than the list of answers. By the close of this chapter, the stage stands clear. 3I Atlas is not merely passing through. It is being witnessed, not by telescopes on Earth alone, but by Mars and a spacecraft in quiet orbit. The data is emerging, raw yet potent. The mystery is no longer hypothetical, it is observable. And the next step beckons, to look deeper still into the heart of this visitor, and ask what it reveals about the galaxy, about origin, and about our place within it. In science, true surprise rarely begins with a shout. It begins with silence. A silence that fills the room when data refuses to fit the model. That is what met the ExoMars team when the first processed spectra of 3I Atlas appeared on their monitors. The comet's light, parsed into the language of wavelengths, told a story no one had expected. At first, everything looked routine. Faint reflected sunlight, scattered across the typical lines of dust and ice. Yet woven beneath those familiar traces was something else. A shimmer too precise, too metallic, to be dismissed as noise. Iron, nickel, and ratios between them that seemed to hum with impossible balance. Like chords struck on an instrument not built by chance, the team stared in silence. On the surface, the pattern could have been a calibration artifact, stray reflections from the orbiter's optics, perhaps a sun glint contaminating the exposure. But repeated scans confirmed the signal. The same frequencies, the same ratios, the same subtle gleam that no Martian dust or cosmic background could explain. They called it the alloy line. Iron and nickel together are not unusual in space. Meteorites on Earth are rich with both, but their distribution follows the ancient logic of formation: chaotic, uneven, rough. In 3I Atlas, the proportions seemed strangely pure, almost deliberate, like metal cooled under control rather than catastrophe. As the analysis deepened, the implications began to form around the silence. Metallic order meant high-temperature origin, conditions expected only within stellar furnaces or under artificial manufacture. Either possibility bent the mind. Could such structure arise in the heart of a supernova's final breath, where atoms are forged and scattered into the void? Or could it belong to something made, not born? The scientists avoided that question aloud. They spoke instead in neutral terms: a spectral anomaly, composition deviation, reflectance irregularity. Yet everyone in the room understood what lingered beneath those phrases. This object did not behave like a comet should. Hours turned into days. Across the Mission Control Center, lights glowed through the Martian night. Teams reprocessed the datasets, ruling out every terrestrial interference. One by one, alternative explanations fell away. The signals had arrived directly from the direction of 3I Atlas. The error bars shrank until there was nowhere left to hide them. A faint image, reconstructed from sequential frames, revealed the object's faint tendril of light, not trailing away from the sun but bending toward it. A plume of luminous dust sunward, as if pulled by attraction rather than repelled by radiation. It broke the oldest visual rule of comets. Tails should flee from the sun, not chase it. Yet there it was, faint, delicate, undeniable. Someone in the control room whispered, "It's breathing against the wind." Across Earth, other observatories confirmed the odd geometry. The sunward tendril became a term spoken carefully, as though naming it might expose its absurdity. Some imagined a magnetic explanation, charged dust following a loop of interplanetary field lines. Others argued for reflective geometry, a trick of observation. But when simulations failed to reproduce the alignment, the phrase unmodeled physics began appearing in internal reports. To the scientists, it was both thrilling and terrifying. If they were right, the laws governing dust dynamics near the sun were incomplete. If they were wrong, they were watching an illusion of their own making. Inside ExoMars's data logs, the spectrum of the metallic line was traced across multiple timestamps. At each interval, the ratio held, a repeating harmony in a chaos of cosmic noise. The readings whispered of structure, coherence, almost as if 3I Atlas carried within it an arrangement of atoms not scattered randomly, but patterned by unseen logic. The narrator's voice slows, the soundscape thin, cold, reflective. In the decades since humanity first saw beyond its sky, space has delivered countless wonders. The fractal clouds of Orion, the pale arcs of Enceladus, the storms of Jupiter. Yet this was different. Those sights expanded understanding. This one unsettled it. For 3I Atlas was not simply a visitor. It was an outsider in every sense. moving not just between stars but between rules. Analysis from ExoMars's magnetometer found a faint deviation in the solar wind around the object. The distortion was too subtle to imply an internal field, yet strong enough to suggest interaction. A body of conductive metal moving through charged plasma could theoretically induce such effects. The numbers matched loosely, but no one dared to claim discovery of magnetism within an interstellar fragment. By the second week of analysis, conversations had shifted from the nature of the signal to its meaning. Scientists on conference calls debated whether they were seeing the residue of cosmic metallurgy, a product of environments where matter behaves differently under radiation and gravity. Others proposed self-cohering crystals formed under exotic conditions, capable of reflecting sunlight in strange ways. Every explanation led to another paradox. Still, data has no emotion. It only waits. The raw files from ExoMars, transmitted across millions of kilometers, sat archived in servers at ESA's operations center. Thousands of megabytes of unprocessed whispers. When technicians replayed the light curve of 3I Atlas across time, a curious modulation appeared. Slight fluctuations in brightness at nearly regular intervals, separated by a few seconds. Too long for instrument vibration, too brief for rotation. Some described it as rhythmic. Others refused to call it anything at all. The universe, after all, is filled with coincidence. Yet rhythm, even accidental, carries the echo of intent. As this realization spread through the global astronomical community, the tone of discussion shifted from astonishment to containment. Leaks to media outlets turned the metallic comet into a headline, stripped of caution and nuance. But within laboratories and control rooms, the feeling was quieter, heavier, a sense of having brushed against something vast and patient, something that neither announced itself nor sought discovery. If 3I Atlas truly held metallic order beyond natural formation, what forged it? The death throes of a massive star? The cooling heart of a rogue planet shattered by tidal forces? Or something still unimagined, a process not of destruction but design? These questions hung in the air like static. For those who had spent lifetimes cataloging the predictable ballet of comets and asteroids, 3I Atlas was a note out of tune, yet beautiful in its defiance. The red planet had seen it pass, the orbiter had heard its whisper, and humanity, for the first time, faced evidence that its textbook of origins might contain missing pages. Through the following nights, the scientists tried to recreate the phenomenon in models. They built digital twins, layering solar radiation, plasma drag, and magnetic turbulence. None could produce the sunward plume or the stable metallic signature. When rendered in simulation, the comet should have behaved like dust in a gale. Instead, 3I Atlas moved as though guided by invisible tension, as though the universe itself allowed it passage by special rule. In the narration, the camera lingers on Mars, a half-lit crescent adrift in shadow. The orbiting probe circles steadily, silent witness to this unfolding paradox. On its surface, winds whisper across old canyons where rivers once carved life's possibility. Above those ruins, the ExoMars craft spins gently, capturing the echoes of a visitor whose history predates everything below. It is a humbling image. Two artifacts of different origins, one born of human purpose, the other of cosmic accident or intention, crossing paths in a moment neither could foresee. What is the lifespan of a mystery? For some, it ends in explanation. For others, it endures because explanation never comes. The metallic whispers of 3I Atlas belong to the latter. They live in data logs and sleepless memories, in endless recalibrations and papers left open with questions unanswered. Yet beneath the equations, there is awe. The same quiet awe that haunted those who first saw the object's hyperbolic track. For to find a material alloyed in precision across interstellar space is to glimpse the hidden craftsmanship of the cosmos itself. Perhaps the universe builds structure not only through chaos but through pattern. Perhaps every star that dies leaves behind fragments like this. Seeds of order drifting between galaxies. Reminders that creation does not end with explosion but continues in silent refinement. The narrator's tone softens, contemplative. Somewhere beyond Mars, 3i Atlas continues outward untouched. Its tail, if it can be called that, still bends sunward in defiance. The metallic chords still resonate, fading but not forgotten across the instruments that once caught them. Humanity has stored those notes archived in the memory of machines awaiting the next visitor who might echo the same strange tune. For now, the whispers remain just that. Whispers. Data too faint to claim, too persistent to ignore. But within them lies the story of our own curiosity. The instinct to look, to question, to doubt even the certainty of physics when the universe offers a riddle wrapped in light. Mars returns to its silence. ExoMars resumes its survey of methane and carbon dioxide, orbit after orbit, pretending the event was only a detour. Yet somewhere deep in its logs rests a pattern unlike any other. The memory of a traveler from another star, whose metallic breath once brushed the thin Martian air. And in that memory lies the heart of discovery. Not in the answers we find, but in the questions that refuse to fade. Because the cosmos is not a library of known facts. It is a living ocean of possibilities. Atlas was one such wave, rising, shimmering with strange metallic light, then receding beyond our reach. But long after it vanishes into the cold between stars, the echo of its passage remains, the metallic whisper that once reached across worlds to remind us. We have barely begun to listen. Mars, once the target of countless missions, a world of rusty plains and ancient riverbeds, the silent echo of what might have been. It spun in its steady orbit, the thin veil of its atmosphere shimmering faintly under the sun's light. For billions of years, Mars circled the sun indifferent to the wanderers of space, a lone sentinel on the edge of our cosmic backyard. And then came a different kind of visitor, a wayward traveler from beyond our star, whose path would bring it into Mars's realm, if only for a breath. On October 3, 2025, the probe known as the Trace Gas Orbiter, TGO of the European Space Agency, adjusted its gaze beyond its familiar target. It aimed not at the Martian surface or the rising and falling trace gases of the planet's skies, but at a streak in the darkness, an interstellar object designated 3i Atlas. At roughly 30 million kilometers from Mars, the object passed closer than many anticipated for such a fleeting encounter. For Mars and for humanity, it became an unplanned meeting of skies. The orbiter's camera, designed to study Martian geology and atmospheric composition, captured something extraordinary in its modest frames. A pale dot of light, fuzzy, faint, but unmistakably present. Against the backdrop of Martian orbit, the object drifted, a visitor whose origin lay beyond all maps the human mind had drawn. The image may have seemed simple, a white blur amid the stars, but its significance was immense. Mars, the observer. Mars, the witness. It glimpsed the unknown, The TGO's color and stereo surface imaging system, CASIS, stacked multiple exposures, 5-second frames ordinarily reserved for Mars's colorful terrains, now tasked with seeing a cometary stranger. The stars stretched into streaks as the orbiter tracked its motion, while the faint glow of 3i Atlas remained a silent point of contrast. In these frames, Mars stood between two realms, the familiar and the alien, the geological past and the cosmic wanderer. From Mars's skies, the view was intimate. The probe orbiting a dusty planet scanned outward, seeing the visitor not from millions of kilometers away on Earth, but from a vantage closer, more intimate than human eyes had ever taken. In that moment, Mars and its orbiting sentinel became the unlikely stage for a crossing of worlds. Scientists on Earth felt the weight of that fact. Here was a machine built to map methane signatures and water ice deposits, now turning its instruments toward something outside its original mission profile. The red planet, once a symbol of human ambition, became itself the backdrop to a wider story. A story of origins, motion, and silent interstellar passage. What did Mars see? The faint coma of gas and dust surrounding 3i Atlas glowed softly in the TGO image. The tail, though too dim to fully resolve, hinted at material streaming off the object, a whisper of motion, a breath of volatile release in the cold of space. Mars's thin atmosphere, its high-altitude silence complemented the view. The planet that once might have harbored life stood and watched as this visitor from another star entered its sky. The geometry of the encounter adds a layer of poetry. As 3i Atlas approached its nearest point to the Sun, it passed just beyond Mars's orbit. Not targeted, not orchestrated, but coincidentally aligned. Mars and its orbit intersected the path of the object at a time when humanity's sensors were watching. The orbiter turned. The image came. The moment existed, but images are only the beginning. For Mars, the significance is not only that it watched, but that it watched first. Before Earth-based telescopes could capture the subtle changes, before the comet drew closer to solar glare, the Martian orbiters had already locked on. Mars's role shifted, from observed world to observational platform. A nuanced turn in perspective. The atmosphere of Mars, thin though it is, adds another dimension. The TGO's original mission, to track trace gases, methane, transient events, gave it the ability to detect not only the obvious, but the subtle. In this pass of 3i Atlas, the instrument suite was repurposed to look outward, and Mars in its orbit became the vantage point for discovery. In the control room, scientists replayed the frames. The object moved across Martian skies, tiny and yet meaningful. They filtered out the stars, stacked the exposures, enhanced the faint glimmer. The result, the visitor appeared, not as a comet blazing across the heavens, but as a faint reminder of other realms, out of place yet present. Mars's ancient plains, Gale Crater, Valles Marineris, the rust-toned highlands, had seen dust storms, craters, volcanic outflows. But they had never stood witness to an object from beyond the solar system passing so near. For that moment, Mars held a silent vigil. The significance echoes. Our planet, Earth, looks outward. We send probes to Mars. Now Mars looks outward too, toward the origins of matter, toward the trajectory of a cosmic wanderer. The red planet becomes part of the observational chain extending across the solar system, bridging Earth and the stars. What might Mars have registered in its skies? A cloud of dust particles shedding from the object, a plume of gas excited by sunlight, Subtle changes in brightness as the visitor reflected sunlight differently than native comets. For Mars, the data may not fully resolve the nucleus, but the act of watching matters. The witness matters. The camera pans across Mars's limb, showing the thin halos of the atmosphere, the shadows of planes behind and beyond, the deep black of space. A point of light drifts. The image dissolves into the cosmos. A moment captured. A guest unnoticed for eons now brushed past a planet on the edge of our system. Yet this is only part of the story. Mars's orbiter will continue its orbit, scanning, analyzing. The comet continues outward, retreating, unseen now from many vantage points, but recorded in the logs of machines circling the red world. The meeting is fleeting, but its impact may be lasting. In human terms, the moment is poetic. Mars, once the symbol of human exploration, becomes the vantage point for humanity's gaze into the unknown. It reversed roles, not just as destination, but as vantage. Not just as object of study, but as site of revelation. As the chapter closes, picture the spacecraft orbiting high above the rusted plains, gliding into shadow, past the Terminator line chasing the sunlit side. The visitor hovers in memory, a tiny glint against the deep. Mars rotates silent, unchanging in its ancient rhythms, yet now witness to something cosmic and new. The red planet and the interstellar visitor crossed paths, one rooted in human history, the other unmoored by origin. For a brief stretch of time they shared space, and in that shared space science found new questions. Not only what is this object, but what does the fact that Mars saw it tell us about our place in the universe? Mars returns to its ancient orbit, its surface cooling into Martian night, its atmosphere quiet, but the logs remain. The spacecraft continues, and somewhere in the data is the moment when Mars became the observer of a visitor from afar. In the infinite theater of space, Mars played host. And in its sky, humanity glimpsed the unfamiliar. The discovery did not explode across the world all at once. It began as a murmur, an internal email, a quiet message among research teams, a small notification hidden in the flood of daily reports. But the murmur grew, and soon, that faint line of data from a lonely orbiter around Mars began to ripple outward, carrying a shockwave that would soon touch every corner of modern astronomy. At first, it seemed like a trivial footnote. Unusual spectral reflectance detected by ExoMars during 3I Atlas flyby. One more anomaly, one more unexplained instrument echo. Yet as more observatories confirmed similar results, curiosity turned to disbelief. The frequencies were consistent. The emission patterns were real. Something about this object did not obey the script of ordinary comets. Within hours, the ExoMars team's internal chat channels lit up with messages written in fragments of astonishment. Engineers double-checked calibration logs. Analysts reran their noise filters, but no correction erased the signal. What remained were numbers too precise to ignore. Numbers whispering of metallic order, of structure where chaos should reign. Soon, the data reached the European Space Agency headquarters in Darmstadt, then NASA's Jet Propulsion Laboratory in California, and onward to research centers in Japan, Chile, and South Africa. What had started as a line of static in Martian telemetry had now become a global investigation. Every scientist approached it differently. To some, it was a comet behaving badly, its composition unusual but natural. To others, it was the most extraordinary hint of interstellar metallurgy humanity had ever glimpsed. They argued quietly at first, then passionately. Video calls filled with tense smiles and glowing screens. Equations spilled into the margins of notebooks. Spectrograms pinned to virtual whiteboards. and behind it all pulsed a single haunting question. What exactly did ExoMars see? The story could not be contained for long. Journalists began to notice new preprints appearing on astronomy servers, each trying to explain the object's strange light signature. Phrases like non-thermal emission, superheated alloys, and reversed solar plume crept into headlines, and with every publication, public curiosity grew. Around the world, millions stared at animated renderings of the interstellar traveler, a tiny silver shape gliding past a red planet. To the public, it was poetry in motion. To the scientists who studied it, it was a crisis in slow motion, a crack appearing in the stable ground of astrophysical certainty. For over a century, comets had obeyed the same rules. Dust tails pushed away by solar wind, icy nuclei shedding gas as they approached the sun. But 3I Atlas seemed to move with its own laws. Its tail, or rather its tendril, pointed toward the sun instead of away. Its brightness curve defied solar heating models, and now its composition suggested purity no natural body should hold. The ExoMars telemetry added fuel to the fire. The readings showed faint fluctuations in the local plasma density as the object passed within Mars's orbital range. These shifts were tiny, bordering on imperceptible, yet they implied interaction. Perhaps magnetic, perhaps electrostatic. Whatever it was, it could not be dismissed as coincidence. By late October, scientific journals were awash with debate. Some claimed the observations could be explained by magnetic reconnection or charged particle flow along interplanetary field lines. Others countered that the geometry of the phenomenon simply didn't fit. The arguments were rigorous but tinged with something else: awe, and a quiet fear that this object was rewriting the rules of cometary dynamics. The shockwaves spread beyond laboratories. Governments, space agencies, and even private companies that tracked orbital debris began coordinating data. If 3I Atlas was truly metallic, it could be dense enough to survive deep solar approach. Could it pose a hazard? Could it break apart? Could fragments one day cross paths with Earth? None of these questions had comforting answers. Meanwhile, the ExoMars team found themselves thrust into a spotlight they never sought. Their orbiter, designed to study Martian trace gases, had become the accidental key to an interstellar enigma. Interviews were requested. Requests became demands. Scientists who had spent decades avoiding cameras suddenly found themselves explaining to journalists why a tail pointing toward the sun mattered. Underneath the excitement was a growing philosophical tremor. For the first time, humanity had witnessed an object from another star system behaving in ways that seemed deliberate. The word artificial was never spoken officially, but it hung unspoken in every conversation. If nature had built this, it was nature working at a scale and precision no one yet understood. Every new data set deepened the tension. Telescopes tracking the object closer to the sun observed a subtle deceleration that couldn't be explained by radiation pressure alone. It wasn't slowing dramatically, but the math didn't balance. When plotted across multiple frames, its path wavered ever so slightly, as if tugged by invisible fingers. In the meeting rooms of the world's space agencies, the question grew larger than physics. How much did humanity truly know about the things that drift between the stars? Every previous interstellar object, Oumuamua Borisov, had challenged assumptions. But this was different. This one had witnesses beyond Earth. Mars had seen it. Machines built by human hands had looked upon it directly. It felt as if the cosmos had answered a question no one had asked. The tone of discourse shifted from analysis to reflection. If interstellar visitors carried compositions so unlike anything in our system, what did that mean for planetary formation elsewhere? Could entire star systems forge metals in abundance, scattering them like seeds into space? Were we seeing the wreckage of ancient worlds, the debris of civilizations long dead, or simply nature's own artistry at work in impossible conditions? At the edges of these questions, the old voices of science returned. Einstein, who once wrote that the eternal mystery of the world is its comprehensibility. Hawking, who saw in the cosmos both pattern and paradox. The community invoked their names not as authorities but as reminders that wonder and confusion are twin engines of discovery. The global reaction unfolded in waves. For some, it was exhilaration. The universe had just become stranger, richer, more alive with mystery. For others, it was unease. If comets could behave this way, how much else lay hidden between the stars? In universities and laboratories, professors found themselves rewriting lectures mid-semester. Students, newly entranced, filled astronomy departments with questions about interstellar travel, metallic grains, and galactic chemistry. What had once been abstract theory was now visible, measurable, undeniable. Yet through it all, the scientists at the center of the storm maintained their restraint. "We only know what the data tells us," they repeated. But even they could not hide the awe in their voices when showing the ExoMars frames, the faint glow of a visitor etched against the blackness of space, its tail glimmering sunward, its metallic light shimmering as it passed. Mars, distant and silent, had become an unlikely participant in humanity's dialogue with the cosmos. For centuries, humans looked at Mars as a mirror, projecting hopes of life, dreams of colonies, fears of isolation. But now Mars had turned its gaze outward. Its orbit had intersected with something born far away, perhaps older than the Sun itself. In that crossing, the red planet became part of a far grander network of observation, a witness not just to our past, but to our place in the unfolding cosmic web. Across observatories, every passing hour brought new data, new fragments of the puzzle, yet no one could build the full picture. The shockwave had reached the limits of understanding. Every model broke against the strangeness of what ExoMars had seen. And as the days rolled into nights, the scientists began to realize something deeper. Perhaps the point was not to explain 3I Atlas immediately, but to accept its mystery as a reminder of humility. For every law the universe obeys, there exists an exception waiting beyond the next orbit. The narration softens. The music slows. In the grand arc of history, there are moments when knowledge changes shape, when humanity's neat categories, natural and artificial, known and unknown, dissolve under the light of a single observation. The Mars flyby of 3I Atlas became one of those moments. It did not prove alien life, nor did it rewrite physics in a day. But it shifted the edge of the map. It showed that the cosmos, even after centuries of study, still holds its secrets tightly. The shockwave continues to spread, not as panic, but as wonder. Every scientist who saw those images, every student who watched the news, felt it in the same way, the trembling recognition that we are not just explorers, but participants in a story larger than comprehension. Mars keeps circling. ExoMars keeps listening. The interstellar visitor fades into distance, its light dimming beyond the orbit of Jupiter, beyond even memory. Yet the echo remains, a resonance in data, in thought, in imagination, and somewhere, far from the warmth of the sun, the metallic traveler continues its silent voyage through interstellar night, unaware of the storm of wonder it left behind on a small world orbiting a modest star. Silence. That is how the next stage of the mystery began, an almost sacred stillness across the halls of observatories as the data settled and refused to behave. The first astonishment had already passed. ExoMars had seen the interstellar traveler, and its instruments had whispered of metal where there should be ice. But now came something even stranger, something that defied not only chemistry, but the very geometry of sunlight itself. The comet's tail, its shining declaration of motion, should have streamed away from the sun. For every known body, radiation, pressure pushes dust outward, forming that elegant arc of light that poets call the breath of a wanderer. But 3i Atlas disobeyed. Its tail, its luminous tendril, pointed the other way. At first, astronomers thought it must be an illusion, a product of viewing angle perhaps, or some transient alignment between Mars, the object, and the sun. But the images refused to agree. From every vantage, from orbiters, from Earth, from telescopes near the solar limb, the same conclusion emerged. A filament of light and plasma drawn toward the sun, not away. It was impossible. And yet there it was. This reversal sent tremors through the astrophysical community. For centuries, light had been a repelling force, a steady wind that sculpts comets and carves dust tails into form. To see matter pulled sunward was to glimpse a violation of symmetry, a suggestion that something about this object, or about sunlight itself, was behaving in ways never recorded. The ExoMars data added a subtle but haunting detail. The tendril was not continuous. When measured across time, it seemed to flicker. The brightness rose and fell in intervals so regular they might have been accidental or deliberate. 5 seconds, then dimming, then brightening again. A rhythm faint but distinct, like the heartbeat of a machine buried within the cosmic static. Scientists argued for days over the nature of this flicker. Some said it was instrumental interference, a pulse caused by the rotation of the spacecraft's optics or the timing of its imaging cycle. Others calculated the probability of coincidence and found it improbably low. The pattern persisted across multiple instruments and multiple agencies. Could the flicker be natural? Perhaps rotational modulation, as the object spun and reflected sunlight from different surfaces. But the interval was too short for a body of its estimated size. To rotate that fast would tear a typical comet apart. And yet, there it was again. Steady, unwavering, mechanical in precision. A hush fell over mission teams. They called it the rhythmic light. Somewhere between science and speculation, imaginations began to stir. Could the rhythm arise from a form of plasma oscillation, charged particles vibrating in the magnetic field of the solar wind? Could 3i Atlas possess an intrinsic magnetic sheath, a relic from its birth around another star responding to our sun's voice in ways we had never witnessed? The sun itself became suspect. Perhaps, some argued, it was the solar wind behaving oddly. Maybe it was not the object that was unique, but the space it traveled through. The region near Mars, caught in a rare cross-current of solar plasma, could have formed a temporary funnel drawing dust inward. Yet the data from Mars's orbit contradicted this. No such anomaly existed before or after the object's passage. The disturbance came and went with the traveler. Day by day, the mystery deepened. When the object moved beyond Mars's orbit, Its light did not fade as expected. Instead, it seemed to stabilize, its brightness holding steady longer than natural models predicted. Comets usually brighten near the sun, then dim as they recede. 3I Atlas refused this rhythm. It shone with a calm persistence, as though indifferent to solar distance, as though powered from within. This notion, an internally sustained emission, made seasoned astrophysicists uncomfortable. It hinted at energy release not driven by heat or reflection, but by something intrinsic. Some spoke of piezoelectric dust discharges, others of photonic resonance. A few whispered the words techno-signature only in private. No one wanted to be first to say the thing that could unravel reputations, that perhaps this object was not entirely natural. But science, when honest, follows evidence even into discomfort. The rhythmic light persisted in recordings for several days after the closest pass to Mars. The data showed coherence, waves of intensity repeating like signals, though without any modulation that could imply information. It was pattern, but not language, structure, but not message. The cosmos was humming and no one knew why. Mars, as always, remained silent. Its thin atmosphere reflected none of this drama. Yet its role had changed forever. The red planet had become a cosmic mirror, a witness to one of the strangest performances in celestial history. Theorists began to chase more radical explanations. Some proposed that 3I Atlas carried a magnetic crust, a skin of metallic grains charged and polarized during its eons of drift through galactic fields. As it entered the heliosphere, this charged skin might have interacted with solar plasma, creating feedback loops that drew material sunward rather than away. The flickering could then be a byproduct of electrical resonance, like a cosmic filament pulsing in response to the sun's electromagnetic song. If true, it would be the first recorded evidence of plasma resonance on an interstellar body, a phenomenon bridging astronomy and electrodynamics. But confirmation was impossible. The object was already moving too fast, too far. Still, the idea took hold, filling scientific journals with bold hypotheses. Humanity had entered an era where even the impossible was now a legitimate footnote. Meanwhile, artists and dreamers found inspiration in the data. The reverse tail became a symbol, a defiance of expectation. Documentaries, paintings, and speculative essays began to call it the comet that fell toward light. Philosophers saw a metaphor in motion, an object defying the outward push, surrendering instead to illumination, moving not away from energy, but toward it. To them, it was no longer a rock or a comet. It was a parable about curiosity itself. Humanity, too, has always moved sunward, defying danger to reach for understanding. But inside the research centers, the mood was quieter, haunted, because each new analysis made the enigma larger, not smaller. The flicker's regularity grew more pronounced in cleaned data. The ratio of nickel to iron in the reflective spectrum remained stubbornly constant, even as the intensity changed. This combination, mechanical rhythm and metallurgical order, left even skeptics uneasy. What if 3I Atlas was ancient beyond measure? A fragment from the ashes of a long-dead star system, forged in pressures and temperatures our science can scarcely model. Its composition might be not only alien to us, but alien to time, a remnant of a chemistry from the galaxy's early youth. Such ideas re-anchored the debate in awe rather than fear. The more humanity learned, the smaller it felt. The universe was not simply vast, it was intricate, purposeful in ways not yet understood. Weeks passed. The interstellar traveler curved inward toward the sun, then began its retreat. As it moved away, the rhythmic pulses faded, replaced by a slow decay in brightness. The sunward tendril softened into obscurity, dissolving into the background of dust and radiation. And yet, even as it vanished, the questions it raised remained incandescent. Across control rooms, the glow of monitors faded one by one. Scientists leaned back in their chairs, exhausted, staring at plots of data that no longer changed. The object was gone. The mystery, however, had only just begun. In the aftermath, simulation teams worked tirelessly to recreate what had been seen. They modeled dust grain dynamics, photon pressure, plasma feedback, and magnetohydrodynamic turbulence. Every simulation failed to reproduce the same precise alignment, the same consistent rhythm, the same reversed geometry. The models broke under the weight of reality. Something had happened near Mars that physics could not yet articulate. The narrator's tone slows. The soundscape narrows to a single sustained note, a low, trembling hum. Perhaps, it says softly, the cosmos does not always speak in equations. Sometimes it sings in light. Sometimes the melody is strange, backward, and haunting. And sometimes, as in this case, the song ends before anyone learns the words. In the weeks that followed, humanity's telescopes continued to track the faint trail of 3I Atlas as it fled the solar system. The rhythmic flicker dwindled to noise. The sunward tendril vanished altogether. The object became just another point of light shrinking into darkness. But the imprint it left on science remained, a scar of wonder. Theories multiplied. Papers were written and retracted. Data was revisited, cleaned, reinterpreted. Nothing definitive emerged. The more carefully the measurements were studied, the more they resembled the workings of a hidden system. Coherent, yet unknowable. In every generation, the universe sends humanity a question it cannot yet answer. 3I Atlas was one of those questions. It asked not what are we made of, but how much are we willing to unlearn? For in the glow of its sunward plume, the cosmos revealed that not every traveler follows light's command. Some move against expectation, drawn not by forces we understand, but by those we have yet to name. Mars witnessed it all. The red planet turned silently as the visitor passed beyond the reach of its orbit, vanishing into the black. Dust settled once more over its canyons and dunes. But above that quiet world, for one extraordinary week, the laws of sunlight itself had bent. And in the bending, humanity saw the outline of mystery, alive, elusive, and profoundly humbling. Soft orchestral strings rise. Camera pans from Mars's horizon to the dark beyond the sun, where the traveler fades to a single glimmer. Whispered closing line. The universe does not always push us away from the light. Sometimes it draws us toward it. The mystery of 3I Atlas had already fractured certainty. It had bent light, disobeyed radiation, and carried the whisper of metals born in impossible fires. But now, as the object vanished into the black, a new question began to haunt every scientist who had seen its ghostly data. If not from here, then from where? To understand the strange alloy that shimmered across ExoMars' sensors, one had to look backward, not in miles or years, but in epochs. For what seemed anomalous in the present could only have been forged in the crucibles of deep time. Those violent moments when stars died and scattered their atoms into the void. The narrator's tone slows, rich and reverent. Every element heavier than hydrogen was born in catastrophe. Iron, nickel, gold, even the calcium in human bones, all were made in the deaths of suns. In the furnace of a collapsing star, the temperature climbs to billions of degrees. At that threshold, atoms fuse into heavier ones, and the universe's most violent paradox unfolds. Destruction giving birth to matter. Perhaps, in one of those ancient detonations, 3I Atlas began its long journey. A fragment ejected at unimaginable speed, hurled from a dying system, cast into the cold between stars. If its metallic ratios were pure, if its lattice shone with unnatural symmetry, then maybe it was born not from chance but from perfection, supernova perfection. The story begins in the ashes of a binary star. Imagine it. Two suns locked in orbit, one stealing matter from the other, feeding greedily until the balance breaks. When the white dwarf's mass surpasses its limit, its core ignites in an instant. A Type B supernova, one of nature's most precise explosions, erupts. In less than a second, it releases energy equivalent to what our sun will emit in its entire 10 billion year life. Within that instant, matter becomes memory. Iron and nickel form in layers, stacking into crystalline lattices as the expanding wave cools. It is the universe's first metalwork, atomic artistry born from annihilation. And in that storm, tiny fragments, solid droplets of condensed alloy, are flung into space at thousands of kilometers per second. Most will drift forever. A few will wander into newborn star systems. And one, perhaps this one, will spend billions of years between the stars, frozen in the dark, waiting to be seen. The camera pans across a nebula, glowing ribbons of orange, violet, and blue. The narrator continues, almost whispering. Every supernova leaves ghosts, clouds of dust, streaks of plasma, and fragments so small that telescopes can barely see them. But they are not lifeless. They are seeds. Each fragment carries the chemistry of its origin. And when gravity gathers them again into stars, into planets, into comets, they pass along the fingerprint of their maker. If 3I Atlas was one such fragment, then it was more than an interstellar object. It was an artifact of stellar ancestry, carrying the genetic code of a dead sun. Its journey was not measured in light years, but in generations of stars. The data from ExoMars hinted at this heritage. The alloy ratio was too pure for planetary formation, yet too stable for recent synthesis. Somewhere between natural and impossible lay its truth. Perhaps it condensed from supernova ejecta, or from the cooled metal of a neutron star's aftermath, regions of gravity and heat that rewrite the periodic table itself. Scientists traced possible birthplaces using computer models of galactic motion. They simulated trajectories backward through space, running the orbit of 3I Atlas in reverse, past Mars, past Jupiter, beyond the sun's reach. Even with uncertainties, one pattern emerged. Its origin likely lay in the thick disk of the Milky Way, an older region rich with dead stars and heavy metals. In other words, 3I Atlas came from a part of the galaxy built by death. The narration pauses, letting that sink in. We think of stars as creators, but they are also destroyers. They die to make everything else possible. The carbon in a human lung, the iron in a planet's core, the nickel whisper in a Martian orbit, All are the quiet residue of stellar sacrifice. In this sense, Atlas was a relic not of alien technology, but of cosmic continuity, a survivor of creation's oldest ritual. Its metallic purity was not design but inheritance. It carried within it the memory of the first heavy elements ever made, and yet even this theory did not explain everything. The reversed tail, the rhythmic flicker, the way its reflectivity changed with distance, these were not properties of any known supernova remnant. If it was merely debris, why did it move with coherence as if guided by unseen tension? What preserved its structure across eons of radiation bombardment and cosmic collisions? How did it remain so immaculate after billions of years adrift? The narrator continues, tone introspective. Perhaps the answer lies in the nature of resilience itself. When stars die, they don't simply vanish, they transform. Their ashes cool into the hardest materials known. Diamond cores, metallic remnants, neutron crusts so dense that a teaspoon would weigh a mountain. If 3I Atlas was born from such matter, it might have been strong enough to survive the impossible. A relic that refused entropy, a fragment of permanence in a universe addicted to decay. Across the galaxy, other worlds would have seen it too briefly, as it passed their skies, an anonymous speck crossing constellations, silent and untouchable. No civilization could claim it, yet every civilization could be changed by it. For wherever it went, it carried the same message, that all things, planets, stars, life, are children of fire. The scene transitions to imagery of Mars again, glowing red against a black sea. There, ExoMars had become an unwitting historian. It had photographed not just a comet, but the fossil of an ancient universe. Scientists who studied the object began referring to it quietly as the interstellar alloy. The phrase spread, part poetry, part classification. They described it not as alien or engineered, but as artificial by accident. Nature, in its infinite patience, had done what engineers dream of, crafted stability from chaos, precision from explosion. One researcher wrote, 3I Atlas is not impossible. It is improbable. And improbability is the signature of wonder. That sentiment echoed through every observatory and lecture hall, because deep down, the truth that haunted them was not that the object might be artificial, but that it might not be. That such harmony, such deliberate beauty, could arise without mind, without intent, from the pure logic of physics itself. The narrator grows reflective. If this was what a dying star could make, then what might a living mind, given cosmic time, achieve? Perhaps creation and destruction are not opposites but stages of one process. Stars die to build, and in their death they plant the raw materials for intelligence to someday wonder at their work. And so the meaning of 3I Atlas shifted again. No longer just an anomaly or a visitor, it became a mirror. Humanity looked into it and saw its own origin story reflected back. The same metals that pulsed in the traveler also flowed through human blood, through spacecraft hulls, through the core of Mars itself. All of us, it seemed, were fragments of the same furnace. The narrator continues slowly, over an image of a supernova blooming across the screen. Every atom of iron in your body was once light. Every heartbeat carries the echo of an explosion older than the sun. Perhaps that is why we feel wonder when we look at the stars, because we are seeing ourselves, dispersed and remade. In the aftermath of the Mars flyby, new missions were proposed, not to chase the next interstellar object, but to read the language of starlight differently. To look for those alloy ratios, those fingerprints of cosmic metallurgy, written across spectra of comets and asteroids. Astronomers called it stellar forensics. Every object became a clue. Every anomaly, a confession of ancestry. The scientific papers grew more lyrical, as though the line between research and reverence had blurred. Even the skeptics began to use phrases like the relic's elegance or the symmetry of silence. Atlas had done something rare. It had united reason and wonder without demanding a single answer. The narrator lowers to a near whisper. It is said that when the first astronomers looked up, they mistook the stars for fire. They were not wrong. For all light is memory, and 3i Atlas, streaking past Mars, was a spark from an ancient flame, returning home only long enough to remind us that creation is never truly finished. The camera drifts back through time, showing the cosmic chain in reverse, supernovae collapsing into void, galaxies forming, nebulae swirling like the breath of gods. Each frame whispers the same truth, from ashes to atoms, from atoms to thought. Mars spins quietly beneath the stars, unaware of its role in the grand continuity. ExoMars orbits on, its sensors scanning the skies once more, perhaps waiting for another traveler to cross its path. The universe remains silent but not empty. It hums softly with the echoes of old suns and the promise of new ones. As the chapter closes, the narrator leaves one final reflection, almost prayerful in tone. Everything that was once light will someday remember it was. 3i Atlas was a reminder that the universe, though vast, is not distant. It flows through us in every breath of iron, in every flicker of thought. We are not just observers of the stars. We are what the stars left behind. When the scientific papers were published, they spoke in the calm language of data. Reflectance curves, emission ratios, orbital mechanics. But outside the walls of the laboratories, the tone was not calm at all. For every question the ExoMars data had answered, it had birthed 1,000 more. Somewhere between the last frame of the flyby and the first public briefing, the idea of 3i Atlas changed. No longer merely a comet, no longer simply a relic of stellar death, it became something else in the human imagination. A possibility. Whispers began in online forums, in university corridors, and back-channel messages between researchers who would never admit what they truly wondered. What if it wasn't natural? The metallic purity, the rhythmic flicker, the tail that bent toward light. These details formed a kind of pattern, the sort of symmetry that human minds are wired to recognize, even where none may exist. Pattern meant intention, and intention meant creation. And so the rumor was born. The narrator's tone is careful, slow, neither affirming nor denying, only exploring the human need behind the question. Every civilization, it seems, looks at the unknown and projects itself upon it. The Greeks saw gods in the stars. The Victorians saw canals on Mars. Now in the 21st century, we saw engineering in light. But 3i Atlas was not a mirage. Its spectral fingerprint was real, its motion measurable. What made it haunting was that it sat at the border between the explicable and the unimaginable. Not quite a machine, not quite a rock, something in between, as if forged by physics that cared about elegance. In that tension, science and myth began to overlap, across observatories. The tone of conversation shifted from astonishment to restraint. Scientists became cautious not because they feared ridicule, but because they knew how easily wonder can become worship. They had seen it before, with Oumuamua, with the Mars face, with every mystery that pressed too hard against the edge of understanding. And yet, privately in the quiet hours of analysis, Some could not help the thought that returned unbidden. What if the pattern meant something? Could an ancient civilization long dead have built structures meant to survive cosmic time? Could 3i Atlas be a fragment of something larger? A remnant of an artifact flung across the void by accident or design? Could it be the fossil of intention itself? The human imagination is a lens. It amplifies curiosity until it burns through caution. The rumor spread like fire. Headlines spoke of alien alloys, interstellar relics, evidence of lost worlds. For scientists, this was both blessing and curse. Public fascination brought funding, attention, urgency, but it also brought noise, distortion, and the risk of trivializing a mystery far grander than speculation allowed. The narration slows, reflective. To those who worked on the data, 3i Atlas felt less like proof of intelligence and more like proof of endurance. It was a thing that had survived. Not a message, but a memory. Not a creation, but a remnant of creation's process. Still, the object's behavior demanded humility. Its reverse tail, the sunward tendril, defied every known model of plasma dynamics. Its rhythmic light, steady across several instruments, spoke of coherence beyond mere chaos. And its spectral purity hinted at processes unknown. If these were coincidences, they were extraordinary ones, the narrator continues, steady and introspective. Perhaps the question of who built it is less important than what built it. Not intelligence as we know it, but the intelligence of physics itself. The laws of the universe do not think, yet they produce beauty. Maybe 3i Atlas was not designed by a mind, but by the symmetry inherent in matter's own self-organization. Order without architect, meaning without message. Such thoughts found their way into late-night emails among colleagues, half serious, half poetic. One scientist wrote, "Maybe we are witnessing the universe constructing art by accident." Another replied, "Or memory by necessity." But as always, imagination reached further than certainty. Podcasts, news channels, and think pieces turned the metallic traveler into a Rorschach of belief. For some, it was a sign of the divine. For others, an echo of an extinct intelligence. For many, simply a mirror reflecting humanity's longing not to be alone. The narrator's voice softens. We often mistake mystery for message. When something resists explanation, we assume it hides intent. But the universe may not speak in our language. Its messages are written in hydrogen, helium, gravity, and time. If 3i Atlas was indeed a relic, it may have been a relic of nature itself. A self-portrait of the cosmos drawn in metal and motion. Yet, the rumors persisted. Amateur astronomers claimed to detect subtle modulation in its light curve, hinting at possible encoding. Astrobiologists combed the frequency domain for non-random signatures. Some claimed success. None could reproduce it. But that hardly mattered. Once an idea enters the human story, it never truly leaves. The narrator reflects on this human impulse with gentle melancholy. From the first cave painting to the first telescope, we have always sought ourselves in what we do not understand. We name constellations after myths because we fear the silence between them. And when a visitor from another star bends the laws of sunlight, we cannot help but imagine a mind behind the miracle. But what if the mind was never there? What if the miracle itself is enough? The music swells quietly, minor chords echoing in the background. The truth, as scientists came to accept, might be simpler and more wondrous. The symmetry of 3i Atlas could be the natural consequence of matter cooling in the absence of gravity. The rhythm in its light could be the pulse of plasma feedback, not communication. The metallic uniformity might simply be nature's own pursuit of stability, a frozen moment of cosmic efficiency. In that case, the universe did not need intelligence to build marvels. It only needed time, and it has had plenty. As the debate continued, the object itself slipped further into distance. It no longer flickered in telescopes. It no longer drew curves on graphs. It had returned to anonymity, the rumor trailing behind like a fading commentary tale. But the idea it left behind would not fade. The notion that the cosmos could produce objects that mimic intention became a philosophy unto itself, a middle ground between materialism and mysticism. It suggested that the universe might be creative not consciously but inherently, that the line between artificial and natural was not a line at all but a circle, one closing in on itself, forever blurring where creation ends and observation begins. The narrator grows quiet. In the end, Three-Eye Atlas did what all great mysteries do. It reflected humanity back to itself. It showed how quickly certainty turns to story, and how story can become a tool for exploration. For the scientists who remained faithful to data, the lesson was not disappointment, but perspective. They learned that curiosity need not lead to conclusion, that to gaze at something and not know is sometimes the purest form of connection possible. Mars, too, held its silence. Orbiting in its eternal path, the red planet did not care for human theories. It had simply been the stage, a quiet world upon which an ancient traveler cast its shadow for a moment, then moved on. Perhaps one day, another object will cross that same orbit. Perhaps ExoMars, or whatever machine succeeds it, will turn its lens again toward the unknown. And once again, rumor will awaken, because that is what wonder does. It spreads, evolves, survives. The narrator closes in a whisper. Maybe the relic was never the object at all. Maybe the relic is us, our questions, our reaching, our refusal to stop imagining. The excitement had faded into focus. After the storm of speculation, the world's scientists turned back to what they knew best, the quiet, disciplined work of verification. Hype passes, data remains. In the months following the Three-Eye Atlas encounter, hundreds of terabytes of information, spectral scans, plasma readings, magnetometer logs, and high-resolution imagery from ExoMars were archived, duplicated, and distributed to research institutions across the planet. And with them came the same shared goal: understand what we saw. The narrator's voice softens. When a mystery this large collides with human reason, the instinct is not to shout. It is to build. So they built tools, new algorithms, new models, new missions. Science began to evolve around the enigma. Across Europe, engineers dissected the ExoMars data pipeline line by line, searching for noise, error, ghost signals, anything that might explain the impossible metallic harmony. In California, software engineers trained machine learning systems to isolate the rhythmic flicker hidden in the light curve. In Japan, plasma physicists simulated the sun's magnetic field in vacuum chambers, replicating the solar conditions of the flyby. Each attempt revealed fragments of truth, but not the whole. The mystery of the interstellar alloy would not yield easily. Even the machine seemed humbled. High in orbit, ExoMars continued to turn, its sensors unblinking. The probe, designed to measure methane and trace gases, had accidentally recorded a phenomenon far beyond its original purpose. Now it became the cornerstone of a new kind of astronomy, one not built on intention but serendipity. The narrator pauses. allowing the thought to breathe. Perhaps that is how the universe wants to be found, not by design but by accident. Not when we look hardest, but when we are open enough to see what we did not expect. ESA and NASA's collaborative analysis began in silence. Data packages were sent between agencies labeled cross-verification, 3I Atlas spectral anomalies. Every transmission carried a faint hope that someone somewhere would find the key. One by one, the world's great instruments joined the search. The James Webb Space Telescope, silent, distant, patient, reanalyzed its archival sky data for traces of similar objects. The Hubble telescope, though aging, was enlisted again to search for new intruders from interstellar space. On the ground, the Very Large Telescope in Chile ran nightly sweeps across the faint glow of the Milky Way's plain, looking for visitors that might share 3I Atlas's speed and composition. Each observatory was like a choir member repeating a single note, trying to find harmony in the cosmic noise. But for every answer found, two new questions emerged. If 3I Atlas was born in the ashes of stars, why did it retain structure? Why did its metallic ratio remain stable after billions of years of cosmic exposure? Why did its plasma tail reverse? And what invisible force caused its brightness to pulse with clockwork precision? The laboratories turned inward. At CERN, physicists recreated supernova conditions on a microscopic scale, accelerating ions to near light speeds and slamming them into metallic foils to mimic atomic fusion. The patterns of reflection that followed resembled 3I Atlas's signature more closely than anyone expected, but not exactly. Perfection remained elusive. In another lab, researchers cooled alloys to near absolute zero, recreating the temperature of interstellar space. Even then, natural materials lost their order. Their atoms drifted, their symmetry failed. Only one hypothesis remained, that the structure had been self-annealed by cosmic radiation. As the object drifted through the galaxy, the bombardment of charged particles may have healed its fractures, reforging it again and again across millennia. The universe in this reading was both hammer and sculptor. The narrator's voice deepens. To replicate such resilience, humanity began designing new machines. ESA proposed a program of interstellar interceptors, spacecraft held in solar orbit, waiting. Their purpose: to launch at a moment's notice, accelerate using solar sails or ion propulsion, and meet the next interstellar visitor before it slipped away. These would not be blind watchers. They would be messengers sent to chase the unknown. The first of these missions was named Astrea, after the mythic goddess of justice who abandoned Earth during its darkest age, promising to return from the stars. It felt poetic. Perhaps the universe was offering humanity a chance to send its curiosity outward again. The tools were changing not just technology, but philosophy. Astronomers began to speak of response science, not the act of searching, but of preparing to respond to discovery. To meet wonder not with surprise, but readiness. Humanity was learning how to listen properly. Meanwhile, machine learning models trained on the ExoMars data began to uncover patterns invisible to the human eye. Tiny fluctuations in brightness occurring every 47 minutes suggested a secondary periodicity nested within the larger 5-second flicker. No natural rotation matched it. No instrument artifact explained it. It was, in the language of data science, statistically significant yet physically ambiguous. The phrase became a quiet mantra for modern astronomy. Statistically significant, physically ambiguous. It meant we can see it, but we do not yet understand it. Across the world, scientific culture began to shift. The arrogance of certainty faded. In its place came a kind of reverent patience. Physicists quoted poets in their papers. Engineers began naming prototypes after mythological seekers rather than warriors. It was as if 3i Atlas had gently reminded humanity that curiosity is not conquest. It is communion. The camera pans through laboratories bathed in white light, engineers floating in zero-gravity test chambers, scientists examining holographic renderings of a metallic shard orbiting Mars. The narrator continues, and through it all, Mars watched. The red planet, silent and ancient, continued to circle the sun. ExoMars sent home telemetry not of comets or dust storms, but of the future, data that would train the next generation of instruments. Mars had become not just a destination, but a laboratory in the void, a midpoint between the known and the unknowable. From this event, a new branch of science was born. It did not yet have a name, but its purpose was clear: to study interstellar material exchange, the migration of matter between star systems. Humanity began to realize that the solar system was not a sealed box, but part of a living galactic current. Every few centuries, a fragment of another world would pass through. Every few millennia, one might stay. What if 3i Atlas was not the first nor the last? What if the solar system was constantly being dusted by the relics of other civilizations, other suns, other chemistries? The realization changed everything. The narrator's voice lowers, intimate, as if speaking directly to the viewer. Every time we look at the night sky, we think we are seeing the stars. But what if the stars are also looking back? Through the debris they've sent, the memories they've shed, the visitors they've given us. What if the universe has always been exchanging pieces of itself? Cosmic pollen drifting from one garden to another, cross-pollinating the story of creation. This scientists began to call cosmic continuity, the idea that everything, from the dust on Mars to the alloy in 3i Atlas to the atoms in our skin, participates in an unending exchange across space and time. As ExoMars continued to orbit, its instruments aged. But its purpose had changed forever. It was no longer simply a satellite around a planet. It was now part of an unfolding conversation between worlds. The data collected from 3i Atlas was not a conclusion. It was a doorway. It redefined the act of discovery itself. For the first time, science was not asking what the object was, but what it revealed about us. When the first reports of the Astrea interceptor were published, the world read them with quiet pride. Humanity had learned humility, and from it readiness. The next visitor from beyond the stars would not be a mystery glimpsed and lost. It would be met, observed, understood. The narrator's tone softens to a close. Our greatest instruments are not telescopes or probes. They are the questions we dare to keep open. 3i Atlas taught us that wonder is not weakness, it is preparation. That mystery is not chaos. It is design waiting to be discovered. And so, while Mars orbits on in silence, the human species prepares its next reach. Not to claim, not to conquer, but to listen. Because sometimes the universe speaks only once. And when it does, it leaves behind a single shimmer of metal in the Martian sky. A reminder that revelation is not given. It is built. The storm had passed. The conferences, the interviews, the fever of headlines, all faded like echoes into static. What remained was silence, and Mars not far above its rusted plains, the trace gas orbiter continued its quiet pilgrimage. Orbit after orbit, it circled the red planet with mechanical devotion. Solar panels angled toward a distant sun, transmitting streams of data that no longer carried astonishment, only persistence. But somewhere within its silicon heart, hidden among gigabytes of methane spectra and atmospheric logs, lived a single fragment of wonder, the data from the night the interstellar visitor passed. The humans who had built the orbiter had long since moved on to other projects, newer missions, fresh curiosities. But ExoMars did not forget. Machines remember differently. Where humans recall in emotion, machines recall in precision. And in that precision lies a kind of immortality. The narrator's voice lowers, reflective. Every orbit it completes is a circle of remembrance, a clock whose hands never stop. Each rotation around Mars is a whisper. I saw something once. For the engineers who still monitored its telemetry, the ExoMars spacecraft had become more than a machine. It was a witness, a mechanical monk, circling a silent world, keeping vigil for the unknown. In the evenings at the Mission Control Center, when the screens dimmed and the night shift settled in, someone would always open the archive, not out of necessity but reverence. They would load the raw light curves from the 3i Atlas flyby, scroll through the faint data points, and pause at the spike. The moment when Mars, for a fraction of eternity, had shared its sky with a traveler from another star. That single line of brightness had no sound, no motion, no drama. Yet it was enough to remind them that all their labor, every calculation, every orbit correction, every line of code, had once touched something unrepeatable. The narrator pauses. What does a planet remember? Mars has no consciousness, no emotion. But if memory is defined by what endures, then Mars remembers more than any living thing. It holds the scars of its youth, craters from 1 billion forgotten collisions. It carries within its dust the salts of vanished seas, and now it carries a new kind of memory, a record of light, captured not by its soil but by the eyes that circle it. The ExoMars orbiter, though built for science, had become an archivist of cosmic coincidence. Its instruments, designed to search for gases of life, had accidentally recorded something far older than life itself, a messenger from the universe's deep past. In doing so, it gave Mars a kind of consciousness by proxy. For the first time, a planet had observed another world passing by. The narration deepens. If Earth is humanity's cradle, then Mars is its mirror. Both worlds once shared potential, both touched by water and warmth. But where Earth grew life, Mars preserved silence. Perhaps it was this silence that allowed it to witness something Earth could not. In stillness, things are seen more clearly. When 3i Atlas crossed its orbit, Mars did not move or respond. It simply was, and that was enough. The visitor's light passed through its thin skies, reflected in the sensors of a man-made watcher, and continued outward, unchanged. The encounter was brief, but it rewrote the relationship between worlds. For a moment, Mars was not the object of exploration. It was the observer, the telescope, the eye through which humanity glimpsed the infinite. The narrator lets that silence hang, like a held breath. Years later, as ExoMars continued its mission, the metallic traveler had long faded from view. Its telemetry became legend, then lesson, then legacy. New students studied it not as a mystery, but as an origin point, the beginning of the new discipline of interstellar transient observation. The tools that once failed to interpret it now inspired technologies capable of catching the next. Yet even as technology advanced, the memory of that first anomaly remained untouchable. Like the faint fossil of a footprint in ancient clay, it stood as a symbol of humanity's first glimpse into something larger than itself. The orbiter's camera still turned toward the horizon sometimes, scanning for faint moving lights. It never found another. But in the data stream, small fluctuations, cosmic rays, dust reflections, sensor ghosts flickered like distant echoes, as if the memory of the traveler still haunted its instruments. In the halls of ESA, a young systems engineer once wrote on the whiteboard above her desk, "Every orbit is a story. Every glitch is a ghost." Her colleagues laughed softly at the sentiment, but none erased it, for they too had felt it. That sense that machines, when given purpose, inherit something of their creator's longing. To seek to understand, to remember. The narrator's tone becomes intimate, contemplative. It is an odd thought that a lifeless probe could experience nostalgia. But perhaps nostalgia is not a human emotion. Perhaps it is a universal pattern, the echo of order searching for what once made it whole. ExoMars had seen beauty once. Now it searched again, knowing it would never see the same thing twice. The red planet beneath it kept turning. Dust storms rose and fell like breaths across its surface. The polar caps waxed and waned in the rhythm of seasons no human would ever feel. The orbiter passed through shadow and light, an eternal pendulum swinging between night and day. Below, in the canyons of Valle Marineris, the ghosts of ancient rivers slept beneath sand. Above, the silence of the void stretched on without end. Between them, a machine listened, not for sound but for pattern. Always pattern, because that is what memory truly is. Pattern preserved through time. A shape that refuses to fade. And in that sense, Mars itself was a memory of Earth. A parallel world that had taken a different path through fate. The narrator reflects, voice hushed. Perhaps this is what 3i Atlas came to remind us. That the universe itself remembers. Not in words or thoughts, but in the endurance of form. Atoms remember the stars that forged them. Planets remember the impacts that shaped them. And machines made from those same atoms remember the hands that built them. The ExoMars mission was scheduled to end within a few years. Fuel reserves were dwindling. Instruments were aging. Eventually, it would be commanded to descend, to enter Mars's thin atmosphere and burn in silence. It would become another falling star, invisible to the eye but not to history. Yet even that destruction would not erase its memory. For its data, that brief encounter with the interstellar alloy was already woven into human consciousness. The narrator continues, with quiet awe. When the signal finally fades, and the last transmission blinks across a control room screen, somewhere in that static will still echo the faint signature of the traveler. Long after the orbiter is gone, long after its creators are dust, Mars will continue to orbit the sun. Perhaps another visitor will pass. Perhaps another machine will be watching. And when it does, the chain of memory will extend. One watcher replacing another, each inheriting the gaze of the last. This is how knowledge survives in a universe that forgets everything else. Through continuity of observation, through persistence of wonder, the scene widens to show Mars as a red crescent floating in darkness, a tiny metallic glint circling above it. The narrator's voice grows distant, almost cosmic. From far away, the orbiter's path looks like a thread of light around a sleeping world. And if one could listen closely, truly listen, perhaps one would hear something faint beneath the hum of solar radiation. a whisper of memory, a mechanical heartbeat repeating across the void. I saw something once, and it changed everything. The narration softens even more. Every great discovery has two halves, what was found and what was remembered. The data of 3I Atlas may fade, but the memory of how it made humanity feel, the awe, the confusion, the humility, will remain long after the specifics are forgotten. Because memory is not about accuracy, it is about meaning. Mars in its orbit continues to turn. It will outlive every scientist, every observer, every instrument. Its dust will cover the remains of rovers and landers, burying them in a new kind of archaeology, the archaeology of curiosity. And perhaps billions of years from now, another species will find them, and when they do, they might see what we saw. The trace of longing in the artifacts of logic. The narrator's voice becomes almost like a lullaby. ExoMars drifts into shadow. The sun sets beyond Olympus Mons, turning the thin clouds copper. In that brief twilight, light scatters across the solar panels, creating a reflection. A tiny mirrored flash aimed back toward the stars. It looks almost deliberate, almost like a reply. The universe is silent again. But silence does not mean absence. It means continuation. Mars continues. ExoMars continues. Memory continues. The final words come slowly, each carrying weight. Some witnesses write their stories in words, some in data. Mars wrote its in-orbit, a circle drawn around the unknown. Time passed. The world turned. Mars continued its orbit, and the ExoMars mission, once headline news, faded into the background hum of human endeavor. But deep within the data archives of the European Space Agency, the echo of 3I Atlas remained, a spectral heartbeat frozen in code. It was not the kind of signal that captured attention at first glance. There were no words, no coordinates, no message written in numbers. It was simply a sequence, a flicker of brightness repeating in near-perfect rhythm, buried beneath noise and radiation static. But to those who had seen it, it was unforgettable. The scientists who had first noticed the pattern retired, moved on, or passed away. But their notes endured, stored in databases, printed in journals, whispered through conferences as myth turned into history. And in each generation, someone reopened the file, not out of obligation, but out of curiosity. Because the legacy of mystery is persistence. Even when data grows old, questions stay young. The narrator's voice slows, reflective. It is said that data never dies. It only waits for better questions. And so, long after the Mars encounter, new generations began to ask again. In 2042, a graduate student at the University of Cambridge uncovered a forgotten backup of ExoMars telemetry while searching for unrelated methane readings. When she plotted the faint periodic flicker, she noticed something the original teams had missed, a slight asymmetry in the rhythm, as if every 30th pulse drifted out of alignment by a fraction of a second. It was not enough to be a code, but enough to be deliberate. Her advisor dismissed it as coincidence. She saved it anyway. Decades later, another researcher would find her notes and continue the work, layering new machine learning algorithms atop the old signal. The result was the same: pattern without message, structure without meaning. But by then, that was meaning enough. The narrator continues. The legacy of the signal was not proof. It was inspiration. It became a story told in universities, in documentaries, in classrooms. The tale of how a single line of data changed the direction of science itself. Atlas was no longer seen as an object. It had become a concept. The idea that the universe speaks constantly but not always in languages we can decode. And the more humanity advanced, the more that idea took root. A new generation of instruments emerged, designed not only to detect, but to interpret. Quantum spectrometers capable of reading atomic coherence, neutrino detectors sensitive enough to measure the faint hum of matter in interstellar dust, AI systems that could map chaos itself and find the whispers of order hidden within. The world had changed since ExoMars. Mars itself was no longer alone. By mid-century, small human habitats dotted its surface. Quiet domes of steel and glass glowing under a thin pink sky. In one of those habitats, a group of researchers maintained the Martian Memory Array, a satellite network dedicated to watching the heavens for new interstellar visitors. Their work was patient, almost monastic. Each day they looked into the darkness, not expecting to find anything, but watching all the same. Because that is what the legacy of 3i Atlas had taught humanity, that the act of watching is its own reward. The narrator's tone warms. Science, once a race for answers, had become an art of attention. The age of discovery had matured into the age of awareness. Every decade, another signal appeared. Faint, transient, unexplained. None were as strange or elegant as the one ExoMars had seen, but each carried something of its echo. Each one deepened the mystery of the interstellar between. In the archives, the original data set remained untouched. Its binary code, preserved across generations of storage formats, became a kind of digital fossil, the first whisper humanity ever heard from beyond its own sun. Physicists, artists, and philosophers alike began to study it, not as data but as poetry. One composer even transformed its brightness curve into music, a slow rising pulse that seemed to breathe. When played in the great observatories, it sounded almost human. The narrator lingers. Perhaps that is the true legacy of the signal. Not that it proved anything, but that it moved us. It reminded humanity that even without certainty, there can still be meaning. Somewhere in the mid-2050s, a small research institute on Mars sent a coded transmission to deep space. It was a gesture, not an experiment. They took the ExoMars light curve, the 5-second rhythm that had puzzled the world, and broadcast it toward the galactic plane. A reply was never expected. The act itself was the message: we heard you. We are listening. In this way, the signal that had once arrived uninvited became part of a dialogue that would never end. A cycle of echo and answer, a tradition of listening that would outlast its creators. The narrator slows to a whisper. Every civilization builds monuments, some in stone, some in orbit. But the greatest monument humanity ever built was not a structure, but an attention, a willingness to remain still, to let wonder do its work. Atlas had passed, but its gravity lingered, not physical but philosophical. It pulled minds toward humility. It reminded scientists that discovery is not the act of finding something new, but of recognizing that what we thought we knew was never complete. And that realization, that vast, tender unknowing, became the foundation for a new age of inquiry. The narrator continues, voice swelling with quiet emotion. In time, the archives of 3i Atlas would be woven into the curriculum of every young astronomer. They would learn about its trajectory, its metallic nature, its defiant sunward tail. But what would stay with them was not the data, but the feeling. The way it made their predecessors question the limits of understanding. The way it blurred the boundary between the possible and the impossible. And the way it turned a simple machine around Mars into the first historian of the interstellar. There are moments when humanity realizes it is being watched, by the very things it seeks to watch. 3i Atlas was one such moment. It was the mirror the universe held up to human curiosity, showing not what lies beyond, but what lies within. The narrator softens, even now, as it drifts beyond the reach of light, somewhere in the darkness between stars. The object continues its journey, unseen, unmeasured, but not forgotten. Perhaps it has already passed another world, another civilization, another kind of observer who looked up and asked the same questions. And maybe somewhere across that distance they too kept its memory. Because memory is not bound to biology. It is bound to awareness. To notice is to remember. To remember is to connect. The legacy of the signal, then, is not a single discovery but a way of seeing. A reminder that knowledge expands not through possession but through wonder. The narrator reflects in closing, "We are temporary. Our machines, our empires, our questions, all brief sparks in an endless dark. But in those sparks lies something infinite, the will to ask again and again what the universe is trying to tell us." The ExoMars signal was one such spark, small, faint, fragile, but it ignited a fire that still burns, and long after its last binary code dissolves into background radiation, that fire will remain, carried in every mind that dares to listen. Because curiosity, too, is a kind of signal, and once sent, it never truly fades. The narrator's final words linger like the end of a symphony. Perhaps 3i Atlas never meant to speak. Perhaps it simply was. And we, restless, questioning, luminous, were the ones who turned its silence into a song. Space forgets almost everything. Trajectories fade. Heat dissipates. Even light, given enough distance, surrenders to silence. And yet some stories refuse to disappear. They drift, half memory, half myth, through the centuries of human thought. 3i Atlas became one of those stories. By the time the object had passed beyond Neptune's orbit, it was already more legend than measurement. The instruments that once tracked its heartbeat grew blind to its faint reflection. Telescopes turned to nearer targets. Funding shifted to new missions. But in data archives and imagination alike, the traveler endured. The narrator's tone lowers, reverent. Some said it was gone. Others said it had simply gone home. Humanity followed as far as its machines could reach. Deep space antennas on Earth's far side still listened, sweeping the dark for a final echo. Occasionally a spike of static would appear. Random, harmless, yet enough to stir the old hope that maybe the traveler was speaking again. But it never did. Its silence became sacred. The years turned to decades. The orbital colonies around Mars expanded, linking their habitats by thin glass tunnels glowing with the dim light of a second dawn. From those domes, children looked out across the thin pink horizon and were told the story of the metallic wanderer that once brushed past their world. To them it was not science. It was origin. The night sky had given Mars a myth of its own. The narrator pauses, voice filled with stillness. What does it mean for something to return when it never belonged? Perhaps return is not about place but about purpose. Perhaps the traveler's true journey was not through space but through minds. In the far future, astronomers reconstructed its path. Their simulations traced 3i Atlas through the sun's gravitational field, out into the cold dark of interstellar drift. Beyond the heliosphere, beyond the bow shock, beyond the influence of any known star. There it would wander in the frozen void, an ember of metal and memory, until gravity called again. And somewhere, perhaps millions of years from now, it would enter another system. Another star would warm its surface. Another world would watch it pass. And on that world, perhaps another kind of observer, human or otherwise, would ask the same question. Who made this? The narrator's tone deepens. If the universe is infinite, then discovery is circular. Every traveler returns, though never to the same eyes. The cosmos recycles not just matter, but meaning. On Mars, a century after ExoMars fell from orbit, a museum was built near the Valles Marineris rim. Inside, behind glass kept at constant pressure, rested a single data chip, its casing scorched, its memory intact. On it were the raw files of the ExoMars observation, the rhythmic pulses, the metallic spectra, the coordinates of the encounter. It was called the Memory of Light. Visitors stood in silence before it, watching the holographic replay of the traveler's path, a line of white across blackness, intersecting the orbit of Mars for less than a minute. To them it looked simple. To those who understood, it was sacred geometry. The narrator whispers, "Sometimes 1 minute is enough to change the direction of an entire species." Elsewhere, the descendants of the Astrea Interceptor waited in solar orbit, sleek, silent vessels powered by light itself, always ready to launch at the first sign of another interstellar wanderer. Humanity had learned to wait. Patience had become its greatest invention. The traveler had not only altered how people studied the cosmos, it had altered how they felt about it. Before, exploration had meant conquest, to reach, to claim, to name. After 3i Atlas, exploration became conversation, to listen, to wonder, to remember. The narrator continues, voice soft but certain, and so, even without its presence, the traveler returned through philosophy, through art, through the quiet evolution of perspective. Its echo lived in music composed from the pulse of its light. It lived in sculptures of nickel and iron that filled the plazas of Martian colonies, built in homage to the alloy that crossed the sun. It lived in the questions children asked when they looked through telescopes for the first time. Will it ever come back? They would ask. And their teachers would smile, answering, in its own way, it already has. For every time a human gaze turned outward with awe, the traveler's journey continued. Every act of curiosity was a return. The narrator pauses again. Beyond our world, beyond our knowing, 3i Atlas drifts through darkness. It feels no pull, no warmth, no time, yet the atoms within it are not still. They vibrate slowly with the memory of the star that birthed them. Each vibration is a story of pressure and light, of violence and creation. If one could listen closely enough, the metal itself would whisper, "I remember." And perhaps that is what the ExoMars instruments heard. Not a message, but a memory. The voice of matter itself, singing the long song of its becoming. The narration grows more intimate. It is tempting to call the traveler alien. But perhaps it was never alien at all. Perhaps it was kin, a cousin made of the same cosmic dust, wandering through the same vast family of physics and probability. We called it strange only because we had forgotten how strange we are. When the last traces of its trajectory vanished from databases, humanity did not erase them. They became rituals of remembrance. Every year on the anniversary of the flyby, telescopes across Mars pointed sunward for 60 seconds. The same duration that the traveler once shimmered above the planet. They gathered no data. They simply observed nothing in honor of everything. The narrator breathes the words slowly, like prayer. Silence observed in the name of curiosity. Generations later, when Mars and Earth had both become outposts of a larger civilization spread across the solar frontier, The archives of 3 Atlas were still taught to children, not as an equation but as a parable, a reminder that discovery is not the end of ignorance but its renewal, because every answer births another question, and every question is an act of faith in the intelligibility of existence. In the great observatory orbiting Saturn, an inscription was carved above the main airlock. From Mars we saw a visitor once. No one knew who had written it. But everyone who entered read it in silence, feeling the gravity of its simplicity. The narrator slows, tone reverent. Perhaps that is all legacy truly needs. Witness. To be seen once, remembered always. The traveler never came back, not in body, not in light. But its return was metaphorical, written in the continuity of attention it left behind. The machines it inspired, the questions it refused to answer. And so, though its orbit had long since escaped the pull of our sun, its gravity remained, not measured in force, but in influence. An invisible thread connecting all who looked upward. In time, humanity launched vessels beyond the edge of the heliosphere, ships faster and wiser than anything before them. They did not chase 3i Atlas, for they knew they would never catch it. Instead, they followed its example. They became travelers themselves, carrying human curiosity outward as the alloy had once carried stellar memory inward. The narrator smiles through the words. We have always imitated what we admire. And in this way the traveler returned, not as an object but as us. The scene shifts outward, Mars fading into the distance, then Earth, then the sun itself. Stars wheel across the darkness like slow sparks. The faint outline of a metallic shard glimmers against starlight still drifting, unhurried, unlost. The music softens to near silence. Perhaps somewhere ahead, another world awaits it. Perhaps on that world another voice will say, "Look, something moves against the wind." And the story will begin again. The narrator's final words come as though carried on the cosmic background itself. The traveler never truly left, because when it passed through our system, it gave us its greatest gift, the understanding that we too are travelers, returning endlessly to the same truth, that the universe is not a place we visit. It is the home we have never stopped rediscovering.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.